Domain can mean all sorts of things, from your URL address on a website to the home that you live in. In algebra, a domain is the set of all possible input values of a relation or a function. Sometimes this can be a challenge. So, can every value on the x-axis be used as an input for a function or a relation? Let's look at some examples. On set mapping or ordered pairs, the domain is only the data written, and we write the set of the domain as D colon, and then we use this funky bracket 1, 5, and 8. On the table, the domain is the input list. So over here it is written D colon 1, 2, 4, 6, 9, and 11. On a graph, there's a lot of different ways to read the domain. On a scatter plot, it's a little bit easier. Now, notice the funky axis. This is not a normal type graph, which they will throw some strange ones at you. The origin is not in the corner, so be careful with that. So on this scatter plot, the domain, and I'm going to guess here at the values, is about 1/2, 2, 3, 4, 5, 6, 7, 8, 9, and 10. On this continuous line, you can see that the domain or the x values could be any number along this line. We would think of this line as a bunch of points just conjoined together. So we would say that the domain is all real numbers on this number line. And it's written D colon, and you would use the bracket, and you would use this funky R. It's got the double lines. Sometimes it's written in kind of calligraphy R, but when I write it, I'm going to use these double lines, and that means all real numbers. Verbally, this is where it gets even most challenging. In this problem situation with the necklace, I just want you to think about, could the necklace have an infinite number of beads? Could it have negative beads? Could it have 0 beads? Now, in this problem situation, verbally, it gets really tricky. So I'm just asking you to think about this because we will be discussing it later in the year. I don't expect mastery right now. The range can be considered an area where you wander. That's why I chose that song for the intro. So the range of a function or relation in algebra is a set of all the output values of a function or relation. Looking at the same examples as before, but now we want to concentrate on the values of the y-axis. That's up and down. On the mapping and the ordered pairs, now we're going to use the range capital R colon. The range is written in proper order. Notice that I went R colon A, B, C. not necessarily in the listed order of the problem here. On the table, the range is 10, 20, 30, 40, 55, and 65. Graphically, on the scatter plot, and again we have that funny axis, and I'm going to kind of guess at some of the values here. The range is 0, 2.5, 4, 6.5, 9, 11, 13, 15, 17.5, and 20. Now, our most challenging problems are the verbal ones. So on this necklace situation, I want you to think about, can the output of this problem or this necklace be infinite? So could we have an infinite length for our necklace? Because that's what our output would be. Would we want our necklace to be, dragging the floor? Probably not. So I don't expect mastery with these verbal situations, but I do want you to think about them. Now let's look at a fun graph like this one for a little bit of a challenge. Notice the scales over there on the right. Each line, the x scale, equals 5. And the y scale, I made that equal to 5 also. So if the domain is all of the input, or x values, and the smallest value x can be right here is just under 5. So let's say it's about 4. And the largest x value can be is 34. We can use an inequality, so I'll put 34 over here, an inequality to state that our domain values is between 4 and 34. This is a sneak preview of a later lesson called set notation. Now let's look at the range. What's going on up and down? That's over here on the y-axis, or f of x axis. The range is all the output values. And if we look at the smallest value for y, that is a little over 5. So we put y in the middle, and the smallest value is 5. And the largest value for y is maybe up here at 17. So I'm going to put 17 over here. And so using the same inequalities, I would say the domain is between maybe, well, it's really a little bit over 5, so we're going to say 5.5. And then it's between 5.5 and 17. Again, this is called set notation. It's a preview lesson. I don't expect mastery at all on it, but I just want you to be familiar with the domain expressed as x between two values and the range as y between two values.